your surname here, Paola Derudas. This meeting is being recorded. This is Paola Derudas, who is based at the University of Lund as part of their department of archaeology and as part of the Dark Lab as well, right? Which I forget what it stands for off the top of my head, I'm sure. Digital Archaeology Lab, I think. Yes. Working with Nico Delunto, who's here next week, and you're completing right now your PhD, aren't you, on and have been developing this piece of software called AIR, which is what you're going to be introducing to us today. Is that a fair summary?
Yes, thank you so much.
It's my pleasure, and I'll hand over to you now. And
Yes. Okay. Thank you so much. And before I start, yes, this is what I want to do. Thank you for inviting me. It's a great pleasure to have you listening to this presentation, and also it will be a pleasure to have your feedback and questions and comments about what I'm presenting today. I had prepared a slide about my work and my but you have already presented it, so I will only add a couple of things concerning my PhD project that focuses on the investigation of new sustainable forms of archaeological data documentation, management, publication, and reuse that exploits the benefits of digital technologies. The main focus of my work was the archaeological report that, together with scientific article, is widely considered the main output and often the only output of most archaeological investigations. And today I'm going to present you the most relevant output of my PhD project. That is also the result of a fruitful international collaborations developed across the 4.5 years. So I'm going to show you today that archaeological publications and specifically the archaeological reports can be strictly connected and entangled with data documentation, management, archival, and reuse if we have the right tool to make it. And talking about excavations, we as archaeologists all know that excavation data management and publication implies the production of huge data sets that are composed of multiple formats and of different sizes. And here at Lund University, we handle excavation data using several tools, like, for example, 3D GIS, that is used, of course, for performing analysis, but also as a kind of archive of the data recorded and collected. And for several years now, we have used a web-based platform for the online publication and sharing of high-resolution 3D models that is called 3DOP. And we can say that our documentation and management approach, even if it can be considered successful, also proved to have some limitations. And concern to these limitations, we identified, for example, the weaknesses of using multiple systems for managing this huge amount of data from excavations. For example, the use of the 3D GIS and the 3DOP, two different platforms for managing and publishing the data. And this causes data fragmentation and the creation of the so-called data silos. Furthermore, the inaccessibility of the GIS data to actual and potential user is also a limitation of the system that we use. And furthermore, the necessary expertise required to use GIS data in an advanced way. And of course, the impossibility of using the data set that is so scattered among different platforms throughout the archaeological process and during the reporting process. Furthermore, a recent review of available publication systems in archaeology indicates the need for a tool that can be used throughout the whole archaeological process, from the field to the publication, and that can allow access the investigation data set in all its part, the data, metadata, and paradata, but also that supports data interpretation and the construction of narratives. Concerning and taking into account all these limitations, is it possible to find a solution? Is there the possibility to have a unique tool that integrates these aspects of data management? And in our case, for example, that integrates 3D visualization and data management. We investigated these aspects, and these aspects are part of my PhD project, and we identified a possible solution in merging a 3D visualization platform that we have already worked with a content management system like OMKS that has been designed for cultural heritage and is oriented towards the semantic web. So this is just an anticipation of the result that I will describe later. And the name of this outpost is AIR, that is the acronym for Archaeological Interactive Report. That is a blended online system designed for recording, archiving, and managing data from archaeological investigations. But I will say more later. So this is just a screenshot of 3 web pages that encompass data set from different excavation projects. And before starting the description, more analytical description of AIR, I want to stress that which are the goals of our work. In order to make it clear what we wanted to achieve. So we wanted to develop a system for documentation, management, and publication of archaeological excavation data that was based on structured data. And we also wanted to define a working model for writing interactive archaeological reports, meaning a solution that addresses specifically needs of archaeologists working in the fields. In order to create a unique tool that embedded 3D visualization and data management aspects, we identified a process that was based on 3 different phases. The design of a more flexible database, the definition of a new data model, and the structuring of the related data, and of course, the identification of the right tool. And of course, I've already anticipated it. I want also, before going ahead, saying that of these 3 phases, the second and the third, in a way, overlapped each other. And probably I will be also able to describe one and to specify when it happened. So looking at the first phase of this process that brought us to the design and development of AIR, we needed to export the database outside the proprietary software ArcGIS Pro to allow non-GIS users to access the data and to connect the database data to other data types. This would also allow to combine these heterogeneous media and formats, ranging from handwritten documentation, like field notes, context sheets, and find lists, to matrix diagrams and pictures of archaeological features and finds that are all necessary to the archaeologists and specialists working in archaeological excavations. And furthermore, having a queryable overarching data set would also allow different data formats and types to be interconnected. And starting from the 3D GIS database, we worked on definition, but starting from the 3D GIS database, on the definition of which we had been working for quite a while, we identified the entities that we wanted to bring in the new system. One of the needs, as anticipated, was to structure our data, and we did it through the use of ontologies. And I don't know, probably it's important to define what is an ontology. Both in computer science and information science define ontology as a way of showing the properties of a subject area and how they are related by defining a set of concepts and categories that represent the subject. So every academic discipline creates ontologies. And the entities that we chose for the new system that we were going to create were described through ontological classes. So we took these classes from existing ontologies, and we chose the most diffuse ontology defined for the cultural heritage field, that is the CIDOC CRM. We also use extensions of the CIDOC CRM that have been developed for domain-specific needs, in this case, archaeological domain-specific needs. So we defined a data model through 14 entities that have been described using 12 ontological classes. So 2 ontological classes were used for more than one of the entity of our data models. And here you see that we created 14, we identified 14 entities. And a nicer way to see how these entities were described by classes from cultural heritage specific ontologies is this one. So 6 entities, the excavation, the context, the stratigraphic unit, excavation unit, investigation campaign, investigation area, group, and feature have been described using classes from ontological classes from the extension CRM Archeo. 2 entity, find or artifact, and person were defined using classes from the CIDOC CRM ontology. And the extension digital of the CIDOC CRM word helped us to define the classes for the ontological classes of 3D models and GIS data. So in this case, we use the same ontological class, that is D1 digital object. And one entity was described through the extension science from the CIDOC family. CIDOC CRM family, and it's the sample. And finally, we have 2 entities that probably are considered not properly archaeological entities, but that in any case are necessary for our purpose to create and to design a system to write archaeological reports that have been described using the bibliographical ontology BIBO. And these diagrams helps to see the interconnection that exists among all these entities. And it's important to observe, for example, that for the stratigraphic unit, for the context, we have two different classes, because as you all know, we have different kind of stratigraphic units. So it was necessary to define their classes according to the specific kind of context that we have to describe. And you also see the relationship that connect these entities among themselves, that are ontological properties. One thing that I wanted to say is that our model also included the site as an entity needed to describe the part of archaeological data set, but in the end, it was not employed in the definition of the model. And this is an example where the choice of the tool, in a way, also had to be taken in consideration when structuring and designing the logical model of the system. Yes, and once we have defined the ontological classes, we refer to ontological properties and standard vocabularies to describe the entities, information, and metadata. Besides the standard vocabularies, we created that are listed here: Dublin Core, CIDOC CRM, and the extensions that we have already mentioned, and also schema.org and BIBO ontology. We needed to create 2 more ontologies that we called AIR and 3DOP in order to define specific properties that were not represented in the existing ontologies. And specifically, the 3DOP ontology is another example of overlapping between the second and the third phase of the process, because we needed that ontology to describe and drive the behavior of 3D visualization aspects within the system that we had chosen to visualize the data and to host all the archaeological data set. And all the entities defined and described in our model share core information, like core metadata that have been described using the Dublin core properties. And here in this table, you see an example: identifier, type, title, description, and date are all properties defined, described using the Dublin core ontology. This graph is another illustration to visualize the logical model of Air. We considered all the whole data set of excavation, including GIS data, 3D GIS data that usually are used and not included in archives. And interesting is to see in this other visualization of the model all the elements, all the entities that constitutes the complexity of the system together with the property that describe them. So entities and their metadata described through these ontological properties. This graph is also accessible from the website of AIR, and maybe if we will have time to look at it in real time, I can show you where it is. And I would like to give you another illustration on how the metadata schema has been used to describe the entities. And this probably will help to see in a more pragmatic way the connections among the entities and the properties. So for example, here we have a context from the Västervång excavation, context 1005, that has been identified by the class A8 stratigraphic units. And it has a unique identifier described by DC terms and a title that has been described as well from DC, using the DC term properties. That the title makes it easier to search for the items to be queried, and it has a type. In this case, is a layer or fill. And it also has a description, again, described by DC term property. And it also has an interpretation. It has been interpreted as a floor layer. But context 1005 was also excavated by a person, that is another entity. And this entity, the archaeologist Andreas Vanson, is identified by an ontological class from the CDOC-CRM ontology. And this person used a specific technique to investigate that context described by a CDOC-CRM property, trowel. And within this context 1005 is embedded a find, the find described through another ontological class, that is the physical thing from the CDOC-CRM ontology. And this object, this artifact, has information connected to its characteristics. So it has a material schema described by a property from the schema.org ontology. It also has a type, it's a bronze object, and it has a triplet of coordinates that helps to locate it in geographically in the 3D model. And furthermore, this object, this artifact, has been digitized, and it's in connection with the digital representation of it, the 3D model that is described by another ontological class, D1 digital object, from the extension of the CDOC-CRM dig. And this object was created by another person, again, another ontological class that identify the person who created it, and also that is the person who acquired the data set, and also it was digitized by another person, described again by another entity, A21 from the CDOC CRM ontology. So we have seen the second phase of the process, defining the data model, and the third phase was to find and test the right tool to design and develop AIR. And as I anticipated already before, we identified it and we decided to name it Archaeological Interactive Report, AIR. That is the integration of the 3D publication platform, 3DOP, into the content management system, or CMS, OMKS. This integration was possible thanks to a fruitful collaboration with the Digital Research Service, le Service Numérique de la Recherche of the National Institute of Art History in Paris, where I spent 6 months during my PhD during the 2021 spring. To see a bit more what are these two components of AIR, I've already mentioned 3DOP, that is a web-based platform designed for the online publication of cultural heritage 3D content that offers, among the benefits of visualization online of 3D models, also the possibility of deep customization. And furthermore, we have quite a confidence with it because we have been using it for quite a while. OMKS instead is a modular content management system designed as well for cultural heritage institutions to connect digital collections with other online resources. OMKS is apt to dynamically design and update websites or multimedia applications, and to handle complex digital contents. The multiple websites that is possible to create into OMKS rely on standard formats and APIs that use data exposition languages and that enable interoperability. OMKS allows more people to work simultaneously on the same documents, and also enable the possibility of creating hierarchized user profiles. So different kind of access to data implementation. Its ability to combine within the same platform the production and the archival of structured data, but also the editorialization and the production of narrative components make it suitable for managing the archaeological investigation data. Furthermore, OMKS allows to create resource templates that can be used to describe the ontological properties of our excavation data and excavation entities. Among the many advantages offered by OMKS, there is also the possibility to adhere to the FAIR principle of findability, accessibility, interoperability, and reusability of data. So we have seen what's behind her, what we have done to design it. Now we can look at it from a user, a reader perspective. And we start with the Vastravong project. The site of Vastravong is an Iron Age central place and settlement in Blekinge. There is a southwestern region in Sweden, where we conducted 4 excavation campaigns, employing digital documentation methods since the beginning of the investigations in 2017. Vong is also the first site where we experimented the use of AIR, initially using data from previous excavations, but also recently, last fall, we used it in real time as a daily working tool, as the main documentation tool during the fieldwork. We have written with my colleagues, Federico Nura from the National Institute of Art History in Paris, and a colleague here, an archaeologist from our department, Andreas Svensson, we have written a paper describing its design and use that was submitted to the Journal on Computing in Cultural Heritage, a special issue on web semantic, and we recently received the reviews. So it's another things that we have to work with. And what you see here is the homepage of the sites of Vestravong. So it is part of the platform R. And as I said before, OMKS allows to create websites, can be considered farm sites or a website farm. And this website contains hosts the whole data set of 4 campaigns of excavation carried out at the site of Vestravong. And we can start exploring or describing the components of it, starting from what is considered, as we said before, the final output of archaeological investigations, the report. And since the design of an interactive report system is strictly related to my dissertation project, I wanted to start from here because it can also be considered a very important element of this system. And of course, it's one of the main goals of my dissertation project. So the report is an editorialization form, a kind of narrative that is enriched with 3D media and that has been built using items that have already been registered in the online archive. So the items used to build and to write this interactive report have been previously recorded in the online archive. And of course, they are also accessible. The report collects all the information that are necessary for the editorialization of an investigation of investigation. I call investigation because it's not only meant to be used in excavations, but also in other kind of archaeological investigations. And it can be built and customized according to the needs of the archaeologist or specialist that is writing it. So can be a field archaeologist, but can be also an osteologist, a specialist of pottery, a geologist, or even a student. Now you see only a screenshot of it, but maybe we will have time to see it also in a dynamic way. But to me, what is important to stress here is that the appearance, the way that the system looks like is the result of a continuous work that we made in order to make it suitable for the archaeologist's use. And in a way, it also resembles some of the standard documents that we have been used to employ in our investigations. For example, the choice of giving more space to the 3D canvas is a specific choice that we made. And also the choice of creating specific icons that allows to identify the different items presented and displayed in the site. Besides the interactive report, there are all the entities that I presented when described the system, when I described the data model of the system. And so we can start with the core of the excavation method that we use, that is the single context method. So this can be considered an interactive context sheet or stratigraphic unit that is the basic elements for the registration or the documentation of archaeological excavations. And we decided to design it as a context sheet with metadata recorded on the left side and also its graphical 3D representation in this case. And you cannot see it here because it's just a screenshot, but if there are items that are connected to this specific item, when we hover them with a mouse, they become red and it is possible to directly access to them. In the case of this context, for example, all these item finds can be directly accessed from this page, from this record. Then we have the artifact. So in this case, this is an interactive recording sheet of an artifact. And as well as the context, display the metadata and the media connected to it. And in this case, we also have a 3D model, but the media connected to the items can also be movies or pictures or PDF files. Then we have, again, as for the context sheet, even in this recording sheet for the artifacts, it is possible to directly access to connected items, in this case, the context or the campaign. Then another item that I mentioned in the previous slides is the investigation campaign. And through this item, we are able to identify the specific investigation information, so administrative information, but also scientific-oriented information. So which are the research questions? And then on the media side, we can access directly to components that are part of a specific investigation campaign. So it is possible to access the tranche or the reports written for that specific campaign. And we have then the investigation area. And this is the item that collects the information about a specific tranche in case of archaeological excavation, because in case of, for example, field survey or other kind of investigation, it can be described as something else and not necessarily as a tranche. This item collects and displays all the 3D contents that have been produced within a specific investigation area. It's a kind of 3D archive that, in my experience of using it, becomes crucial when we work on data interpretation and in report writing. We will see a bit more about the tools that can be used in the 3D canvas. But for example, just to show you or just to describe this one that is visible in the screenshot, these are all the 3D components that are displayed and that are connected as media or metadata to this specific item, and they can be visible or not visible, and they have different labels, color labels, according to the specific nature. So we have finds, we have context, and we have also 3D models described and represented graphically in this item. And talking about 3D models, we also have decided to create item to describe the metadata and the paradata connected to the acquisition and the production of 3D models. And the 3D models are automatically visualized in the interactive recording sheet of the item that they represent. As you saw before, both in the artifacts and in the context sheet, we could see 3D models because there is the possibility to connect them directly. So they can be visualized both in the tranche, in the context, or in the artifact recording sheet. And of course, we also have GIS data because they are a relevant component of archaeological investigations. They allow to spatially describe the position of archaeological features and are enriched with metadata. And AIR allows to import GIS data in the system in an interoperable format, the GeoJSON format, and to visualize GIS data in the report. We believe that GIS data is an essential component if we want to create a unique system that is able to encompass and host the whole archaeological data set. And finally, the paragraph. There is the editorial cell that combined with other paragraphs allow to build the interactive report. How do we use it? So we choose the archaeological features that we need to describe that are connected to 3D media, and we combine them with other information, and we enrich the visualization with the text, or the opposite way, or the other way around. And one thing that we can do is that we can also decide how to visualize and to combine the description of the text and the behavior of the 3D models. And we can do that thanks to one of the items that are part of the air system that I didn't describe. It's called the 3D obscene, but let's say it's irrelevant on a specific archaeological point of view, but it was very useful to have it in order to create predefined view on the 3D components of the report. Yes. This slide, I decided to add it because I described using other kind of diagrams, the connection among the elements. But it's also useful to see this connection from front-end perspective. So how the objects that a user that access the system, that access the website, are connected among themselves. So they are all entangled among themselves, but then the next question is, how do we explore them? How we access them from the database? How can we explore this online archive that I've been talking about before? To do that, we can go back to the homepage of the site. And there are different ways to explore the website. And this is also one of the benefits of choosing a content management system like OMKS. There is a menu in the left top corner of the page that can gives us direct access to the online archive, but also to the other elements and components that build the system. And as you can see here, there is also the possibility to access the graph that we saw before. So if we click on browse, we are directly connected to the archive that contains all the data set registered in the Vestravong site. And as you can see here in the top right of the screen, when I took the screenshot, we had already recorded 555 items. And the way we decided to display them is that we want to display the title because it is a very useful way to search for items in an archive. But we also wanted to display the ontological class and the type, like in case, for example, of stratigraphic unit. But we also wanted to display the description of the item. And furthermore, the archive allows to perform advanced search that can be done to search specific object items in the database, being 3D models, artifacts, specific context, and so on. And now I prepared a very short movie to see how how to read dynamically the report. From the home page, it is possible to access directly to the report, but also to collections, and we can talk about them later. And the report has an icon that allows us to identify it and display information, administrative information, and a connection to Riksantikvarieämbetet, that is the institution through which excavations are permitted, and that is also the institution to which we have to deliver excavation documentation. And reading the report, maybe this kind of read is quite fast, but I just wanted to show you that on the left side, both on the text side and on the canvas side, it is possible to interact with the elements to get information about them. And all the elements that have been chosen to describe a specific paragraph are also displayed as elements on the bottom of the text. And clicking on specific buttons, it is also possible to identify and to change the point of view in order to easy the reading of the report. And as you can see, it is possible to directly access to other items that are represented and picked from the archive, from the database, and chosen to be described in the system. And for all of them, it is possible to get information in a pop-up window, but also to directly access to their specific recording sheet. Another interesting thing that is possible to do, and that's a plus of OMKS, it is possible to, okay, here there is the visualization of the GIS data, and here it takes me a while to get information about it, but it's not only the representation, so polyline, polygons that I didn't upload for this specific campaign, but they also bring with themselves the metadata, so they are GIS feature that also brings with themselves the metadata connected. And as you can see, the different tabs allow to see the different kind of media that have been connected to a specific report. I think, and probably now, yes, one of the interesting thing is that when we access to the browser, we can perform advanced search, and we can search for all the items that are part of the system. So all the elements that we have seen before, the finds, the context, can be queried and visualized. And an interesting component of OMKS that I wanted to say before, now I clicked on a specific gold find that can be indexed. So clicking on the category, I ran an advanced search that shows me all the finds that are made of gold. And yes, I think the movie ends here. I don't know how long I have been talking about, but I have a couple of more examples. In the application of AIR, this is another project I've been involved in, and it's another case study where I had the possibility to test AIR. This is a maritime archaeology, a maritime excavation. It's the shipwreck of the flagship of the King Hans, a Danish king. And this ship sank in 1495 in the archipelago of Blekinge, this region that I also already mentioned before, in the southeastern part of Sweden. This is a 3-year-long excavation so far, and I took part in the excavation activities since the beginning. In this case, we also used digital documentation methods since the beginning of the investigations, and the goal for this project was to identify a data management and the methodological pipeline to challenge the limitations, the intrinsic limitation of maritime investigations, that by their nature are more complex than the terrestrial ones. And furthermore, we wanted to add semantic to the 3D geometry produced. 3D documentation is very has become the most diffuse way of documenting maritime excavations, but not very much has been done to use these 3D models for more than management purposes. During the 2021 campaign, so last year, we defined a new data management strategy where we also started to experiment the use of AIR. And initially, the use of AIR that has been conceived for a single context method appeared difficult in this environment, because in maritime excavations, it's not possible to really employ a single context method. So the use of air highlighted some difficulties when dealing with this different environment. But the representation of archaeological features and artifacts indeed presented some issues. And in this slide, you see the first attempts in the two top images, where we were able to identify and to annotate different finds visible in the 3D models, components of barrels and components like staves and components, and also artifacts like there is a crossbow fragment, and also components, key components of the ship. But so it was very good on a visualization point of view, but it was not very useful on a archival point of view, because we couldn't record these finds in a proper way, because they were just representation of context. So we used in a wrong way the items created in the system. The misuse of the items could affect the possibility of querying the archive and using it for report generation. And we struggle a bit of it, but we found a solution to solve such issues, keeping the same management approach as in terrestrial archaeology and in the single context methods, and to identify context are the core elements of the excavation recording. There is a difference in the way that underwater excavation are documented, because the divers can identify the stratigraphic units, but they cannot excavate them all in once. So they split the context, and during several dives, and the possibility to document this stage of the context excavation allowed us to identify layer spits and to connect to this let's say the void that is obtained by the combination of two consecutive 3D models could be identified as the context, as the stratigraphic unit excavated, and also the stratigraphic units to which the artifacts documented belong to. And so we made this test, and the results were very successful. And as you can see in the bottom screenshot, we decided to represent, in this case, the context split through a polygon, but it is also possible to obtain a volumetric 3D model of it, combining the two meshes and creating the context using the volume, the volume of the void between the two consecutive models. And it was also possible to represent the artifacts retrieved or repositioned in situ using both 3D models, but also, I don't know if you can see it here, there is a sphere, a 3D sphere that we placed there using the coordinates, the geographical coordinates of the find. And during the 2022 campaign, so last August, we used R as the main documentation and data management tool. We were very lucky because we had a team of experts skilled both in data acquisition underwater, but also in data processing. And we managed to publish and to upload into R 60% of the 3D contents that were documented during the excavation. And the results obtained in this use prove that R can be a convenient tool even for real-time documentation of maritime excavations, although of course its use in our experience was facilitated by the 3D expertise. And finally, we have another case study. Schempinge is a Mesolithic site in the Skåne, the region where Lund is, southwestern Sweden. And in this case, this is an example of reuse of data. And we can say that the website of Champing in Air is an upgrade of a prior reporting system version. And we have started to develop it in collaboration with Stockholm University, where the master students of the archaeology course worked with R. They used the data set of a trench from a specific excavation campaign. So the data were already implemented, the data set was already implemented, and the students used this data to rewrite the archaeological report as an assignment from their professor. And we still have to collect the results of this experimentation, but apparently the students were very happy and didn't find major problems in using it compared to previous experimentation with the previous reporting system that was a bit more complicated to handle. And as you can see in all the slides of the website, I provided a link because they are, of course, accessible and open, so they can be explored. We haven't started to advertise them very much yet because we are still working on some, we have still to fix administrative information to add to the website. So we have some more perspectives, the results of using R within as a tool for previous excavation data, but also as a real-time documentation and data management tool were successful. And its use also opened new perspectives. Among them, the possibility to integrate information from a field walking survey, and also to include in this system information connected to archaeological science data that are paramount to create comprehensive archaeological archives. And we have already started to explore these possibilities through internal and external collaboration. So there are colleagues at the department that work a lot with field walking survey that manifested interest in using the system as a documentation and management tool, but also with external specialists, in a specific case, an analytical chemist that was involved in the Gripsunden project, was also interested in testing R to record and archive information from chemical analysis. And another perspective that we have are more referred to the possibility to align our model to most recent archaeological semantic models, like the ones developed in the framework of Ariadne Plus, of which I'm also part, in order to store our RDF data in a triple store to allow data to be queried from SPARQL endpoints. We also planned to make mapping and alignments of the properties of our custom vocabularies to the common reference thesauri, like the Getty Museum Thesauri AAT, and also Wikidata. In any case, we can, these 3 slides, I have to be honest, I've recycled them and we use them with my colleague Federico when we present it, but it's more his word. I'm more the archaeological part of the team, but we can already say that we are satisfied about the fairness of the system because the data is findable. Each item in OMKS as a unique and persistent identifier. And in the same time, in the same way, also the metadata related. The data is described with rich metadata. For each item, we have a complete set of Dublin core metadata about title, description, and we have already seen them. And the metadata and the data are indexed in searchable resources, the web database, and exposed in accordance with the last searching engine optimization practices. Our data is accessible. Our data model is accessible because OMKS has a REST API that is based on standard protocols, PHP, HTTP transfer protocol, and JSON LD publication. And the API used by OMKS also allowed authenticated access to protect sensible data. And all the metadata are always available, even if the rights about some media can change over the time. And our model data is also interoperable, even if I can see that still we have some limitations, and they are concerned to the 3D formats that we chose to use in order to display the 3D model on a web browser. But our custom vocabularies and ontologies are published in RDF format through a namespace hosted by OMAKS itself. And most of the concept that we use to describe our metadata that we used creating custom vocabularies can be and will be linked to Thesauri and structured vocabularies aligned to standard references and gazetteers, as I have already mentioned before, like GeoNames, Wikidata, and AAT Thesauri. And finally, our data is reusable. Each item has a DC term license metadata that specify the license and the right holder that shows the owner of the right. And for the air system, we chose a Creative Commons Attribution License, CC BY 4.0. And concerning the third point, metadata meta-domain relevant community standards, we try to work in accordance with the most recent published best practices. But I recall what I said before among the goals of our project, that is the need to create a tool for archaeologists, created by archaeologists, that can simplify and can allow archaeologists to work with easy to use tools. And this is also the reason why we didn't follow in an orthodox way the guidelines proposed by guidelines or like choices to use a Sidoxyram pure model, Sidoxyram based pure model. And that's it.
Thank you, Paola. Can you hear us okay?
Thank you for listening.
Can you hear us?
Yes, I do.
Thank you very much. There is something in the chat, but it came up a while ago, and I don't know what it is.
Yeah.
Let's have a little look and see if it's. Oh, yes, that's right. It was just someone saying hello. Do we have any questions? We haven't got very long because.
Yeah.
But that's okay. Hen,
I have a question.
shout the screen. Yeah, come closer.
Okay, thank you.
Thanks, so that's really interesting. I was just curious how it handles more traditionally captured data. So things that might not have made it to GIS, things like standard record photography, section drawings, that kind of thing. And my second question was about how you handle relationships across the site in terms of phasing and dating as well.
Okay. Yeah, first, yeah, I think I have heard both questions and understood them. So the first, to the first question, my answer is if sections and other more standard format of documentation are represented to formats that are readable by the system, yes, they can be implemented as media. So for each media of the system, maybe I can share again and give you like show something using the system, the actual system, that can be maybe of help. So if we go in the archive and we chose, for example, a context, and we pick it from the advanced search, and we search for context, field, or layer, and we run the search, and we choose one of them, for example, this one, 1005. In this case, we have 3D models, but if we have the possibility to add drawings or sections, they can be added as media in the system and visualized together with the 3D models, because the system is able to recognize that format as a media and to display it as an object attached to the recorded item. Concerning, I hope I have answered your question. Second question, how we relate chronology and phases among items, is it correct?
Yes, that's correct.
Yeah. We, in this case, and this is something that probably I haven't mentioned enough, in order to avoid misspelling and typos in filling some of the field of our tables, of our resource templates, we created custom vocabularies. And so, for example, we created custom vocabularies for defining the typology of context, the categories of finds, the materials, but also the periods. And already exist standard vocabularies in Thesari, like periodo, and the idea is to use them. And according to this kind of choice, making this kind of choice, it is possible to query the system according to that kind of property and to visualize and collect this kind of information together. On a stratigraphic point of view, concerning instead the physical relationships, one of the things that we also discussed a lot about was the possibility to create and to represent also in the system a matrix scheme of the context that constitute the archaeological data set. And we have some ideas, but at the moment we didn't have the time to create it and to develop it. The only thing that we can see is what we have also in the context sheet. So the possibility to display and define properties for describing the relationships among the context. So below, above, and for example, in our experience, and this is also very interesting because it demonstrates how the choices that we made are constantly connected to what we have or what we work with, or what are the tasks and the needs that we have in the field. We excavated for several years the same excavation area, and the same context was identified and was excavated in 3 different campaigns. So we needed to keep this relationship, to keep this information. And we identified another property, and for that we used a specific ontology to describe it that allowed us to connect the same context excavated in different campaigns and recorded with different identifiers. Yes, I think I don't know if the question was exactly that one, or if you meant something more specific about chronological relationships.
No, it's cool. That's great. Thank you very much. There's one in the chat as well, where someone is asking how easy would it be to reuse this system for other purposes outside of archaeology? For example, restoration of objects and things.
Yeah. The possibility, I mean, the archive, and if you go to this link, to this URL, you can access the system and explore it. Of course, in order to create new contents, you have to be allowed to do that. As I said, it is possible to create different kind of users in order to avoid loss of data. But all the items that are in the system can be used and reused for different purposes. The question you ask is very interesting. Maybe we didn't think about restoration of objects, but we, since we have a very strong collaboration with the Blackingham Museum, and we had a lot of volunteers helping us in the excavation at this site, Västravång, we want to reuse our research data also for dissemination purposes. So we are looking at this possibility. And since OMKS as a content management system allows the creation of multiple editorialization firms, it's one of the possibilities that we would like to explore is to use the same data set to tell the general public the stories of the excavation and how the work has been done, and eventually also present objects as they have been retrieved in the field, but also how they have been restored, or also digitally restored, like in the case of the ship, for example. One of the main goal is to try to reconstruct it digitally, and of course it's not only a matter of archaeological scientific knowledge, but also a matter of provide this kind of information and knowledge also to the general public. So yes, there is definitely the possibility to reuse the data for other purposes.
Thank you very much, Paola. Is there any other questions from the room? Do you have? There's one lurking. Go on quickly then. One last one.
So you were talking a bit about the student excavations and how you I was just wondering how much you were able to use within the field and whether it aided in the interpretations of excavators, of the students, the people digging.
Yeah, you mean this one, I think.
Champion.
Yes, this one. Okay, yes, I can show you. So the thing is, I didn't include this in the presentation, but we had a prior reporting system that was mainly based on 3D-OP. So there was no proper database behind. And the professor who excavated this at this site, as I said, I only reused this data. So this is a case of third reuse of the data set. Wanted the students to use the system after he presented the excavation and all the information. He wanted to use it to let them virtually participate in an excavation during the pandemic, where excavations were not allowed, like field work with the students was not allowed. And the experimentation went very well. So the professor was very happy. And once that he saw this possibility, he was very happy because compared to the previous version of the system, in this case, the students provided with access to the system could pick and choose elements from the archive to write their own report. So of course it was not, okay, this is the data set, to do whatever you want with this data. There was a preparation before. So the students, before starting using the system and before being trained in using it in the proper way, had lecture on the site and on the archaeology at the site. But as I said, we still haven't had a proper assessment in which way using this system improve their abilities in interpret the data and in understanding the archaeological process in general. But it's something that we plan to do.
Thank you. I think we probably need to call it there. But Paola, thank you very much. I'll talk technical details when I speak to you about this soon.
Yeah,
so.
yeah.
Okay. Yeah. Thanks very much for.
Thank you very much for listening.
And we'll be in touch.
Yeah.
Ciao.
Yes. Ciao. See you. Bye bye.
Thank you.
Bye. Thank you.